This video we are going to discuss about bending of beams. So, what do you mean by a beam? Let us start with the word beam. What do you mean by a beam? Beam can be a bar or a rod. A beam means it can be either a bar or a rod. So we are going to study about bending of the beams or bending of bar. Now, to be more specific, we can say that a bar or a rod of uniform, rectangular or circular cross section. A beam is a bar or a rod of uniform, rectangular or circular cross section. Here the most important thing of a bar or a rod is its length will be compared to be much more when you compare it with the thickness in the case of a rectangular bar or a radius in the case of a circular cross section. So what is called a beam? Beam is a bar or a rod of uniform rectangular or circular. If it is rectangular, its length is much considered to be more than its thickness. And if we are saying about a circular, then we can say its radius is much less compared with its length. Okay, see, assume this is a bar, this is a playing game. See, its length is this much. Its length is this much, but see its thickness, it is very less compared to that of its length. See, thickness is only this much, but see the length is this much. So length is much larger than the thickness. So such things we call, or the such a cross section, either a rectangular or a uniform, we call it as a bar or a rod or a beam. Okay. Now, see, this is an example, or this is a diagrammatic representation of a beam. Now, see, we have written that this is a beam. Okay, this is a beam. See, here also there are many layers. Here also there are many layers. So we can see that these layers, they are actually parallel. They are thin layers. And all these layers are parallel to one another. All these layers are parallel to one another. So inside a beam there will be many layers, or there will be many thin plain layers. There will be many thin plain layers that are in contact. See, they will be touching each other. See, since we are drawing, I am drawing with a little bit space in between them. See, but they are in contact with each other, and each layer is parallel to the another. And such a collection of thin fibers or layers parallel to its length. See, this is the length and this is the thickness. So parallel to its length, such fibers are known as longitudinal filaments. Longitudinal filaments of the beam. Longitudinal filaments of the beam. What are the longitudinal filaments? Longitudinal is the word that is related with length. So in a beam there will be many parallel layers which are in contact with each other. These thin parallel layers, they are known as longitudinal filaments of the beam. Okay. Now so we have studied one word, that is longitudinal filament of the beam. What is a beam? Now what is a longitudinal filament? Next is we have to see the term is neutral surface. What is a neutral surface? To study the neutral surface, let us consider this diagram. See, this is a beam, this is a beam, this is a beam, and this beam I have just clamped it here. I have clamped one end of the beam. Okay, I am going to give a stress or a force to one end, what will happen? It will slightly starts bending. Okay. Now, see, when the beam is clamped horizontally here at one end and we are going to give the load or a stress this side, that is force per unit area, and this side, what will happen? It will undergo bending. Bending vary. So we have told that there are many filaments crowded here. One, there are parallel, either cylindrical or coaxial. These layers, there are many filaments that are parallel here, and what will happen? The tension will, when you are loading this beam at one end, ഒരു എൻഡിൽ നമ്മൾ ലോഡ് ചെയ്യുമ്പോൾ, see, each layer will undergo a tension. And what will happen? These filaments or fibers or these filaments of the outward surface, they will get lengthened. ടെൻഷൻ വരുമ്പോൾ അതിങ്ങനെ താന്ന് വരാൻ തുടങ്ങും. അപ്പോൾ അവരുടെ നീളം നമുക്ക് തോന്നും അതിങ്ങനെ കൂടിയതുപോലെ തോന്നും. ബിക്കോസ് ഇറ്റ് ഈസ് ബിക്കം ലെങ്തൻ ഡ്യൂ ടു ദിസ് സ്ട്രെസ്. പക്ഷെ അകത്തുള്ളത് എന്ത് പറ്റും? ഇറ്റ് വിൽ ബി ഫൗണ്ട് ടു ബി കംപ്രസ്ഡ് ഓർ ഷോർട്ടൻഡ്. ആൻഡ് ഇൻ ബിറ്റ്വീൻ ഇവിടെ കംപ്രസ്ഡ് ആയിരിക്കും, ആ ഇന്നർ സൈഡിൽ ഷോർട്ടൻഡ് ആയിരിക്കും. ഇന്നർ സൈഡ് ഇറ്റ് വിൽ ബി കംപ്രസ്ഡ് or shortened, whereas the outer side it will be lengthened. These are the words which are usually because of the stress acting per unit area or the force acting per unit area or the tension. നമ്മൾ എന്താണ് പറഞ്ഞത്? We are having a beam and there are many layers or longitudinal filaments. You are clamping one side of this beam and giving the load in another side. What will happen? This outward side it will lengthen, whereas the inner side it will shorten. And there will be some portion in between these. ഇവിടെ ലെങ്തൻ ആവും, ഇവിടെ ഷോർട്ടൻ ആവും. ഇതിൻ്റെ ഇടയ്ക്ക് കുറച്ച് പോർഷൻസ് അല്ലെങ്കിൽ ഒരു സർഫസ് കാണും വിച്ച് ഈസ് നൈദർ ഇലോങ്ങേറ്റഡ് നോർ ഷോർട്ടൻഡ്, വിച്ച് ഈസ് neither elongated or shortened. That surface is known as neutral surface. That surface is known as neutral surface. And here, see, we can say that here there is a surface. Let here there is a surface which is neither elongated nor compressed. This is EFGH. This is that surface which is neither elongated nor shortened. കാര്യം ഇതാണ് നമ്മളെ ബീം. This is our beam and there are many parallel layers below that beam. ആ ബീമിൻ്റെ അടിയിലുണ്ട്. അതിലെ ഒരു സർഫസ് എന്ന് പറയുന്നത് it is either elongated nor shortened. That is E. Let this be E. EFGH. That is known as neutral surface. That is neither elongated nor shortened. That is called as neutral surface. And this ABCD is known as plane of bending. This ABCD is known as plane of bending. Plane ABCD, plane of bending. That is a symmetry parallel to its length. This is length, and this is a symmetry that is parallel to its length. And this plane intersects every transverse section in a straight line. That is the axis of the symmetry for that section. This is an ABCD, that is the plane of bending. See, when you are bending, what happens? It will intersect or it will intersect all the transverse sections in the straight line. That is, or we can say axis of symmetry. This plane will intersect the axis of symmetry. That is what we call the plane of bending. If the bending is uniform, see, if this bending is uniform, plane of bending, if this bending is uniform, all the longitudinal filaments, or fibers, whatever we call, all the longitudinal fibers or the filaments will bend into circular arcs in the planes that is parallel to plane of the symmetry ABCD. So this is our ABCD, that is a plane of bending. That is, we call that this when we are giving a stress or when you are applying a load to one side, what happens to the bar? It will start bending, and when the beam is bending, it will happen that there will be a plane, that is a symmetrical plane, which will intersect all the transverse sections, or it will intersect the axis of symmetry of that particular section. That is known as plane of bending. And what happens if this plane of bending, or if the bending is uniform, then all the longitudinal filaments, ഇതിലുള്ള എല്ലാ longitudinal filamentസും എന്ത് പറ്റും? ഇറ്റ് വിൽ ഓൾസോ ബെൻഡ് ഇൻ ടു സർക്കുലർ ആർക്സ്. ഇതെല്ലാം പാരലൽ അല്ലെന്നായി പറയുന്നത്. സോ വെൻ ഇറ്റ് ഈസ് ബെൻഡിങ് ഓൾസോ, ഇറ്റ് വിൽ ഓൾസോ ബെൻഡ് ഇൻ സച്ച് എ വേ ദാറ്റ് പാരലൽ ടു പ്ലെയിൻ ഓഫ് സിമെട്രി ABCD. അപ്പോൾ ബീം ബെൻഡ് ചെയ്യുമ്പം ഓൾ ദ ട്രാൻസ്വേഴ്സ് സെക്ഷൻസ് അല്ലെങ്കിൽ ലോഞ്ചിറ്റ്യൂഡിനൽ ഫിലമെൻസും യൂണിഫോം ബെൻഡിങ് ആണെങ്കിൽ ഇറ്റ് വിൽ ഓൾസോ ബെൻഡ് ഇൻ എ സെക്ഷൻ പാരലൽ ടു പ്ലെയിൻ ഓഫ് സിമെട്രി, ദറ്റ് ഈസ് ABCD. ഈ ABCDക്ക് പാരലായിട്ട് എല്ലാം ബെൻഡ് ചെയ്യും. ദാറ്റ് ഈസ് വാട്ട് വി കോൾ പ്ലെയിൻ ഓഫ് ബെൻഡിങ്. ആൻഡ് ദ സെൻറ്റേഴ്സ് ഓഫ് ദിസ് കർവച്ചർ, ഏത് ലോഞ്ചിറ്റ്യൂഡിനൽ ഫിലമെൻസിൻ്റെ എല്ലാ സെൻറ്റർ ഓഫ് കർവച്ചർ എന്ന് പറയുന്നത്, ദേ വിൽ ഓൾവേസ് ലൈൻ എ സ്ട്രെയിറ്റ് ലൈൻ ദാറ്റ് ഈസ് perpendicular to plane of bending. Okay, and this straight line, that is what we call axis of bending. That straight line we call it as axis of bending. And this line of intersection of this plane of bending with the neutral surface, നമ്മൾ നേരത്തെ EFGH എന്ന് പറഞ്ഞില്ലേ, neutral surface, that is what we call neutral axis. That is what we call neutral axis. So let us once again rewind what we have studied. We have just discussed an introduction to mechanics of solids, that is bending of beams. As we told, we are studying about the bending, or when you are how does a beam bend, or when does a beam bend. So before that, the beginning is, what do you mean by a beam? So beam, we have told that either the beam can be a bar or a rod which is having a uniform rectangular or circular cross section, and if the beam is, and each in the beam there will be many parallel layers, ഒന്നിൻ്റെ മുകളിൽ ഇപ്പോൾ തടിയാണെങ്കിലും if it is we cannot see, but we know that there are layers, അല്ലേ? നമ്മൾ layers കാണത്തില്ലേ? യെസ്. അപ്പം അങ്ങനെയുള്ള layers ഉണ്ട്, and the length is considered to be very large compared to its thickness. Such things, or such cross sections, we call it as a bar or a rod or a beam. If you are going to clamp a bar at one side, okay, and you are going to give stress or tension on another side, what happens? The beam will start bending. And when it is a uniform bending, all the filaments also will bend along with that beam parallel to its cross section. Okay, so that longitudinal filaments also will start bending, and we call it as plane of bending. And there will be, see, when you are giving a force, one side it will get elongated, or we can say lengthened, and other side, that is clamped side, will get compressed, or we can say shortened. Okay, it will be getting shortened and other side is getting lengthened. So what happened? There will be some surface in between, അല്ലെങ്കിൽ layers in between കാണും, neither affected, neither elongated nor shortened, and that is what we call, what do we call? That is a neutral surface. elongation നടക്കൂല, shortening നടക്കില്ല, അതിനെയാണ് നമ്മൾ ന്യൂട്രൽ സർഫസ് എന്ന് പറയുന്നത്. Then we can say that ഇങ്ങനെ ബെൻഡ് ചെയ്യുമ്പോൾ അവിടെ ഒരു ആക്സിസ് ഓഫ് സിമെട്രി ഉണ്ടാവും. അതുപോലെ തന്നെ ഈ ലൈൻ ഓഫ് ഇൻ്റർസെക്ഷൻ ഓഫ് ദിസ് പ്ലെയിൻ ഓഫ് ബെൻഡിങ്, ഈ പ്ലെയിൻ ഓഫ് ബെൻഡിങ്ങും ലൈൻ ഓഫ് ഇൻ്റർസെക്ഷനെയാണ് ന്യൂട്രൽ ആക്സിസ്, ലൈൻ ഓഫ് ഇൻ്റർസെക്ഷൻ അതിനെയാണ് വിത്ത് ദ ന്യൂട്രൽ സർഫസ്, ദാറ്റ് വി കോൾ neutral axis, that we call the neutral axis. And these are the main introduction. Okay, thank you.